That's how we can achieve decentralization, and slowly technology will adapt and everywhere it will happen.
Right. Very nice.
That's how I
Yeah.
look at it
Right.
at the moment. And talking about the security of the information, which you asked earlier.
Yeah.
Um, okay,
How are we
let's
gonna make it
yes,
secure?
let's talk about privacy first and then
Yeah.
security.
Right. Like, can we say that Luna was one of the example of security being compromised?
Um,
No, it's false.
yes, in
Yeah.
a way you can say that,
Yeah.
because uh, a hack is always a question on security,
Security. Yeah.
right?
Indirectly.
And something is not secured because, in the first place, it was not made private. If it is private information, so whatever leaks, it is private, no one can read. So first maintain the privacy, then like it's a step towards the security. It's a step towards achieving security. So how do you maintain privacy? Privacy of what? Let's first understand privacy of what? Privacy of a data. So when I say data, you extract information from a data, and what is important? The information. So let me give you an example. Um, I talked about the scalability, like we have to pass information from each other.
Right.
So imagine I have to tell someone in
Yeah.
a community, you are a
Yeah.
human being, I'm a human being, and there are, let's say, 5 other human beings, imagine, and
Yeah.
we are talking about something.
Okay.
And there are 20 human beings, like 20 participants of this trustee or this community, are not right there at this point of time. They are like doing something at their own pace, but they need to know because they're
Part of the.
participants of the
Yeah.
ecosystem.
Right.
You need to pass the information.
Right.
How? You need some technology, digital devices, quick, super, nice. Let's go to the next step, how it happens. Now, with this, I will explain Byzantine fault tolerance.
Okay.
Let's not talk what is Byzantine fault tolerance. Let's just understand that this is Byzantine fault tolerance at this
Okay.
point of time.
Okay.
And I'm going to explain with this example in
Lovely.
society.
Yeah.
So let's say you say, I have to give, so Baba has to give €5 to Charul.
Yep.
And all the 25 participants has to approve it. Now, Baba, name, amount, a value, you as a receiver, your name is important. And there is a check, a normal system. Okay, am I 18 years old? Am I born beyond this? Whatever. Now, this information has to be verified. That okay, is that a real human being? Is there an amount and all these? So, what needs to be checked here? Does Baba have that amount in the account? But there needs to be a software, there needs to be an intelligence which is reading, okay, who has the knowledge that, okay, Baba has €25 or $25 in his account and he is eligible to give $5.
Right.
So instead of asking, like
Yeah.
instead of reading how much I have that, if I ask the system, like ask your intelligence now,
Yeah.
do I need to tell somebody Baba has $25 in his account? No. If I can say others,
Yeah.
Baba has enough amount
Okay.
to pay.
To pay
With
that.
this, I'm not leaking the information of $25 to anybody.
Right.
That's
Right.
privacy.
That's privacy. Wow, wonderful. Very
So
nice
I
example.
made my
Yeah.
information, like that
Safe.
data
Yeah.
there.
Yeah.
So how my brain is working? My brain just took $25, did some mathematics that okay, $5 is less than $25.
That's enough.
And that's enough to make this payment happen.
Lovely.
I am just telling the world, Baba has enough amount to make this transaction.
Lovely.
I'm not telling anybody that Baba has $25 and they will decide. Now they have to run the
Right.
mathematics.
Right.
So when everybody
right.
runs the mathematics, it's a processing. I avoided that processing and I rolled it up to another machine who is doing it. This is zero knowledge. Without knowing the data, you are rolling up that complete process to a certain layer, like the below layer will do this and propagate the information. He's eligible to do this.
Right. And what's
I-
that
yeah.
layer? What's that layer? Is it that this was the example that you have given on Byzantine Fault tolerance.
Yes.
Yeah.
So in this, Byzantine fault tolerance is there when this is validated by two-third group of the people. So now I will give you a similar example in this. Like I will take this example, but I will take you in a different direction to
Okay.
achieve Byzantine fault tolerance of that information.
Right. Perfect.
Now,
Let's go for it.
now some device, some machine, some computer ran some program and told me that okay, Baba is eligible. Now I got this information and I'm gonna tell everybody in the ecosystem. We had 25 members. I'm gonna tell all the 24 members, hey, Baba is eligible, Baba is eligible. Some other guy, like in the same ecosystem, out of those 25, they found out they tried to give you a wrong information. They tried to say, Baba is not eligible. So this is a hack, let's say. So that
Okay.
machine is rigged.
Okay.
That human being is rigged. And that human being is propagating a wrong information to the network, to all the 24 people.
Yeah.
Even I am getting that information. I have given an information and I'm also receiving an information to validate. So all 24 participants of the network will also give me the information. So it's everybody talking to everybody. That's why it's peer-to-peer and decentralized. See, easy peasy.
Right. Easy.
You
peasy.
understood peer-to-peer, you understood
Decentralization.
Now I'll go
Lovely.
one step
Yeah,
further.
yeah,
So
okay.
everybody is propagating information to everybody. So 1 is to 24, and
Okay.
everyone has that 1 is to 24 propagation
Okay.
of messages.
Right.
Now, the machines, like I got the information, so I got 24 AS, 1 no. Same with my other peer, 24 AS, 1 no. 24 AS, 1 no. Now, I will check, do I have two-thirds of the vote to approve this? Yes, two-thirds of the vote is saying, like more than two-thirds is saying yes. So it's approved information. Now everybody will have this information. Baba is ready to make the transaction.
Okay.
So someone will do the transaction now in this machine, like in this ecosystem. So there is a several, election mechanism there. This is why. So it's like normal voting process.
Okay.
Like they vote, okay, now this need to do the work.
Right.
I need to do the work. This guy need to do the work. When I say work, it's some kind of task of
Yeah.
passing information
Okay.
or doing something. When I say doing something, we'll come later to smart contracts and how they can be automated and how Chainlink plays a bigger role there. We'll talk
Okay.
about it.
Right.
But before going there, let's
Tick box there.
end this.
Yeah. Yeah. Perfect.
So this
Perfect.
two-third parties are approving this, that okay, this information is right.
Yeah.
And there you achieve Byzantine fault tolerance, practical Byzantine fault tolerance.
Right.
So it is basically a voting mechanism where two-thirds of the participants approve the whole transaction.
Okay.
That's it.
Right. Can I also ask you, maybe it's going to be a stupid question,
No,
but there are
nothing is
like
stupid.
24 people out there. So one person is sending the message to 24 and everybody has that right. So how is that data stored? Is it stored somewhere? Because it's going to accumulate too much. Like now I'm thinking it from the actual database point of view. The databases that we are using
You don't
right
need
now.
to store this information
You
for
don't.
long. It is just for
Okay.
that amount of time where you need to
Okay.
process.
All right.
So there are several solutions to it. Okay, thank you for asking this
Because
question because I
24
will
into
go
24,
Yeah,
yeah,
good
multiplies
question.
into.
So I
yeah.
will go one step deeper now, like in
Okay.
terms of technology
Yeah.
and relating to human being. You are doing one transaction, so I'm paying €5. Do I remember this information? Ever? Like I paid
well-
€5. I just keep it for accounting. If I come back, I
Yeah.
can see it.
Yeah.
Do I need to remember it forever? Do I need to
No.
store it in my brain?
No.
So do I need
Not
a storage
really.
device for that? No.
No.
The end result, the account information, that is stored.
Okay.
So this particular information is like the way you are quickly doing it and flushing it from your brain.
Okay.
So there is something like that. It's called mempool where the transaction goes and it happens
Gotcha.
in that way. I don't want to go there. What happens inside mempool? Let's keep it for future,
Later.
like
Yeah. Other
not in
episodes.
depth.
Yeah.
So yes, but
Okay.
that's how it happens. Like you can, if you want to compare with Web 2 world, I know there are so many Web 2 watchers as well who wants to transform from Web 2 to Web 3.
Okay.
And if you want to compare there, it's like a cache. It's not a storage and database. It's just a cache, which keeps on flushing. Just compare with that for the moment. We will talk later about mempool and how it works, what happens with mempool.
So, Baba, we were talking about Byzantine fault tolerance algorithm. And that's where, one node sends the message to 24 nodes. Just for an example, we took that example. So 1 to 24 communication style, and every node has
The same
same
information, and they
same
gives a
authority,
message with a validation result.
and same rights. So how can we make this more private? Is it possible to reduce those
Yeah,
nodes from 24?
you can do it like let's say you don't want to tell this or pass this information to 24 of them, and you want to
Yeah.
just let 10 of them to know about it. So
And does it bring, and then it's just merely, the question is to how can we bring more privacy?
yeah,
Why do
so
we,
instead of telling all the 24 participants in this conversation in society, let's say there are
Yeah.
24. Let's make it A to Z, and so we can use each characters as the
Yeah.
human being's name.
Okay.
So let's say A is trying to send a message to B, and B at the same time is trying to send a message to K.
Okay.
So the same information is going because they are just doing their job. So
Right.
let's squeeze it that, okay, for one particular transaction, we will keep only 10 nodes involved.
Okay.
You can do that. And how will you do that? So you need to, instead of sending that information to 20, you need to send it to 10. Now, how is that 10 coming from? We will come to that in a while.
Okay.
But now I need to send those information to 10 people. And
Yeah.
those 10 people will give me the validation
Okay.
to a certain percentage, like two-thirds of this, or you can set your own percentage. Okay, if I get 67% or if I get 51%, I'm happy with this. So with that, you can process that information within those 10 participating nodes instead of all the 24.
Okay.
And how are you going to choose those 10?
Yeah. How are
There
we gonna
comes
choose it?
another challenge of choosing those 10.
Right.
So, or who are those 10?
Okay.
So this is called federation. So instead of 24 all making it public, you kept the information within the federation of 10. Now, how those 10 are decided? There is a particular process of choosing them,
Okay.
and there are several consensus mechanism to choose those 10 number of nodes based on trust, based on their past experience, based on their reputation and all. Yeah, accordingly you choose those 10.
Yeah.
This is why most of the Hyperledger technologies, I'll talk later, for the time being, let's keep it short. Like Hyperledger technologies, they prefer to have a federated Byzantine fault tolerance.
Okay.
Because here the information is not with everybody, it's with those trusted people.
Right.
So federation keeps the information trusted.
Well,
Those,
and-
yeah.
Yeah. Another question is, so when it was 1 to 24, wasn't it that fully? How can we say that? How can we be sure that that wasn't trusted? The information back then wasn't trusted.
Okay, we tried to keep
Yeah.
the like we used to roll up there where we just didn't propagate the data. We propagated the information, yes or no, or something like valid or invalid, allowed, not allowed kind of information we just sent. And that was processed by all the 24, which is if you look at it holistically,
Yeah.
all 24 human beings are using their energy to process this. And so in technology, all the 24 computers or 24 devices are consuming some power to do it. And so there is a processing usage. There is a network lag because processing is there,
Yeah,
and
yeah.
24 people needs to give you result back. Now only 10 has to give you the result back.
Right.
It will be faster.
Right.
So you achieved scalability. Wow. So
Okay.
that's cool. But there is a little bit of processing with respect to practical required in federated because you need to find those 10.
Right. Okay.
So there is a process for this. And this is why it's federated. So
Right,
you keep
okay.
that within the federation.
Interesting. So now, can they? So the Byzantine fault tolerance and federated fault tolerance, they are utilized together.
They are Byzantine fault tolerance.
Okay.
One is practical, one is federated.
Okay.
And the difference is in practical, you give the message to everybody.
Okay.
In federated, you keep it within those trusted parties, within those chosen nodes who are meant to make this thing happen or make this transaction happen.
Right.
So that's the difference, I would say.
Right.
Here, the information go to all. Here, to the chosen one,
Right.
the selected.
Would you also explain a real-time use case at the moment of
Uh,
these?
Yes, Hyperledger Sawtooth, I think.
Hyperledger.
Yeah, they
Okay.
use federation, and
Okay.
if you look at it, this idea came from our like the way we live in the society.
Tell us more about it.
Uh,
Yeah.
yes, so it's like you might have heard about this federation, that federation.
Yeah.
So
In
when
the
we
general
say
governance terms
yes,
like
so
federation, our
because they
federation.
want to have trusted people in the community who
Yeah.
are running a particular part of the business, and they are meant only for that business, and
Right.
that there the federation comes in, and that's what we have brought into technology. That okay, in let's say it is something like okay, if this particular geographical location has a federation, there is another geographical location where there is a federation. So they are running the federation because they are the only trusted parties in that geolocation. So with those being there, you keep the information private within those federation. Yes, federation can talk to federation with some kind of agreements.
Okay.
Like this geographical federation can talk to this geographical federation.
Right.
Like in terms of technology, there needs to be interoperable. This is why there are
Interoperability.
so many talk going on the interoperability, because there are several networks who are keeping their information within their network. I'm not
Okay.
saying they're federation, but if you look at from 40,000 feet, then this network, this network, this network, this network, information is private in that network itself. If they want to communicate, there is nothing at the moment. There are options, but I'm saying there needs the question of interoperability of that information between
Yeah.
different networks. We'll talk about it later.
Right. Okay. Okay.
It's something like a group of people are interested in books. So there is a blockchain network. A group of people are interested in music. There is a different blockchain product or network run by some like enthusiast, you can say. Because technology is in people's reach now. Everybody wants to learn it, and
Yeah.
they're launching their own.
Right.
But is it required or not? We are not yet sure. And
Yeah.
I think there can be layers between these networks.
Okay.
When I say layers, what I mean to say layers in terms of design, not in terms of network layers. So design in the sense there will be one layer who will be serving all these, and they'll be selecting few nodes to do something. So it's a kind of more number of election process through a mechanism of doing something. So,
Okay.
for example, 10 people will choose one leader, and here 10 people will choose one leader. These leaders are like, you know, how do I say? These leaders are the representative of those many number of people, and those leaders can choose their representative who will be running the entire network or something like that. And so, in this kind of mechanism, you might have heard about delegated proof of stake, uh, where the delegation happens. So delegation
Okay.
of what? Delegation of election mechanism. So
Okay.
I'm using Byzantine fault tolerance
Yeah.
in every layer
Okay.
for sending the messages, because Byzantine fault tolerance says send the message to everybody, get everybody's message,
Right.
and check what are they saying,
Yeah.
and check how many percentage of people are
Right.
agreeing to that mechanism or whatever action you are doing.
Right.
So, with that being said, it is there in every layer, because everywhere you are, like in every layer of election mechanism, you are choosing through this process.
Okay.
It is there.
It is there.
But the delegation of the things are going layer by layer.
Okay.
So,
Okay.
yeah.
Interesting. Makes sense.
And
Yeah.
there is a concept like which Chainlink follows, like with just this talk, I've found that I should talk about it right now.
Right.
It will make more sense. Uh, they they have off-chain reporting. So in off-chain reporting, what happens? These social activities that is going in our real world. These information needs to be there on blockchain. It should not be only financial information or any thing that can be digitized. There are so many things which are not yet digitized, and those information needs to be there. For example, weather. Weather information is very vital for insurance industry, for several other industry who are running their beverages or food, because based on the weather, there are
Different
like
variations
yes,
or
in terms of the food
yeah.
choices,
Yeah.
the like hotels or other businesses, travel industry, like everybody plans according to that.
Yeah.
So it's a very vital information,
Definitely
and
weather.
that needs to be. So that information needs to
Needs
come
to be
from
real
more
time.
number of decentralized node operators,
Right.
and so that off-chain information is there and on-chain,
Yeah.
and we are able to run the business on-chain.
Okay.
And Chainlink plays a bigger role there to maintain the consensus of the data. So when I say consensus of the data, it's like, okay, 20 degrees Celsius is approved information
Okay.
by the participants. And who is sending me the information? Okay, I got the information from a leader node. And who is that leader node? That guy is chosen by some other nodes through some consensus mechanism and election process.
Wow.
So this is how they are
Wow.
maintaining
Wow.
uh,
Yeah.
the validity of or the correctness of the information, and it is an approved information by so many players or so many participants in that off-chain world who are running the Chainlink algorithm to give that information.
Okay.
So yeah.
And we do have the real time use cases of how Chainlink is being used currently. We
Yes.
Yeah. We would like to know more about all these use cases where
Yeah. For example,
Chainlink
you
is
are growing
helping.
a tree,
Yeah.
and you need to put that information on blockchain. How will you do that? So there needs to be a human being who comes every day, measure it,
Right.
put the information, and that
Yeah.
information is validated and
Yeah.
brought into blockchain, like
Okay.
it on chain for doing something.
Yeah.
And why is it needed? So
Yeah.
okay, there is some money spent. So if you look at the way the carbon credit calculation happens. So for some amount of carbon dioxide being emitted, there is a plant being planted. So for that, there needs to be, okay, this much amount is gone for planting. Is it really being used or not? Who is going to validate? Okay, donation process is happening on blockchain, but the tree growing process, how can we bring that information? For that, that's off-chain information that needs to come there. So there are node operators working for bringing these
Okay.
like information on blockchain. Second comes parametric insurance industry. It's a bigger one, and they are mostly based on the weather information, rain information, the wind, pressure, and so many weather attributes you can say. So those information needs to be tracked because accordingly the agriculture business is affected.
Okay.
Accordingly, warehouse gets to know the information and they run their business, and insurance companies who are insuring the farmers because it's a thing with the weather and they could not handle it, and so they need to be insured accordingly. So these informations are vital for such insurance
Yeah.
industry.
Right.
Apart from this, there are market data, for example, price feed information from decentralized exchanges. If you compare there is a concept of circuit breaker. I won't go deep now, but I would say something like, based on the market, you want to do some action. So you need to have some system where you need to get that information constantly to do that action. So how will you get that information, and who is going to provide? So Chainlink is playing the massive role
Okay.
to handle those financial fluctuations on decentralized platforms.
Okay.
So for all the DeFi applications to be secure,
Yeah.
you need to have these mechanisms, and
Right.
they can only be achieved when you have that information. So Chainlink is providing that price feed information. And it's not only for price feed. I'm just giving an example. You can integrate any API for that.
Okay.
But I'm saying yes, like it will be more easy in future. Like you just don't need to write so many of the code because it will be something like, okay, you just plug this and things start working. And this Chainlink as a decentralized Oracle platform
Yeah.
is playing the bigger role there.